Hello, this is Dr. Amudataya, Associate Professor at Tripoli, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will see about the SVR, TCR and TSC. SVR is nothing but the static PAR compensator. A TCR and TSC are the most important building blocks of thyristor based SVCs. So what is a thyristor controlled reactor? Normally we used to have two thyristors connected back to back in parallel and is then connected in series with the reactor. This is what is called a thyristor controlled reactor. So the controllable range of the TCR's firing angle alpha will extend from 90 degree to 180 degree. A firing angle of 90 degree results in full thyristor conduction with a continuous sinusoidal current flow in the TCR. The current reduces to zero for a firing angle of 180 degree. The thyristor firing at angles below 90 degree introduces DC components in the current, disturbing the symmetrical operation of the two anti-parallel valve branches. For example, let us consider the source voltage Vs of t is equal to Vm sin omega t. Here we have taken V is the peak value of the applied voltage and omega is the angular frequency of the supply voltage. So the TCR current is given by I of t is equal to minus V by omega L into cos of alpha minus cos omega t. While considering the TCR's operating characteristics, we can see that as the current increases, obviously the voltage is also increasing depending upon the alpha value. If the alpha is equal to 90 degree, then it is a highly linear, but when increasing the alpha value, we can see that the curve is shifting towards the left. And this is a small picture of the TCR. This is how the current value and voltage value will be there for two different alpha values. Next, let us see about the thyristor switched capacitors. So what is a thyristor switched capacitor? Simple. We do have two thyristors connected back to back in parallel and they are connected in series with the capacitor. So we know the capacitor will be charging and then discharging, those effects will be there. So the capacitor voltage is not equal to the supply voltage when the thyristors are being fired immediately after closing the switch. A current of infinite magnitude will flow and charge the capacitor to the supply voltage in an infinite short time. The switch realized by the thyristors cannot withstand this stress and this will fall. So the capacitor voltage is equal to the supply voltage and the thyristor are fired. The analysis shows that the current will jump immediately to the value of the steady state current. The steady state condition is reached in an infinitely short time. Although the magnitude of the current does not exceed the steady state values, the thyristors have an upper limit of di by dt values that they can withstand during the firing process. Here di by dt is infinite and thyristor switch will fall again. So this is how the TSCs and TCR are being connected to the low voltage buses through which the firing circuits are being provided and control action takes place through the AVR. This is the SVC VI characteristics when considering the injection of TSCs and TCR into the system.